Yes. So chapter 3 is on ions, how metals always make positive ions, non-metals make negative ions, and it's by either losing or gaining electrons because the number of protons cannot change. And so we practiced putting ions together to make ionic compound. And we use the crisscross trick, unless you see already, like for example with Ba2+ and S2-, that one of each ion is enough to make a neutral formula. And so then you just write the formula by putting the two ion symbols next to each other. So this table that we have left to do is doing the reverse process of what we did at the end of last Zoom meeting. This time we have the compound formula, and we want to find the ions that this formula is made of and write the name. So let's start. So out of Na3PO3, so it's important to have the table that lists the name and formulas of common polyatomic ions, right? You want that page out. And the periodic table as always. So can you tell me, and please use the chat for that. So tell me the symbol of the cation in Na3PO3. So type that in the chat. I want the name of the cation, the positive ion. Yes. Na is sodium. Sodium is a metal, an alkali metal from group 1A. And so it makes the ion Na+. It's a predictable ion. You know its charge from the position in the periodic table. So group 1A means it's going to be +1 for those metals. And then PO3, this should be obvious to you that it's a polyatomic ion, right? It's more than one element there. And it's two nonmetals. P and O are nonmetals. It's phosphorus and oxygen. So you want to look at your list of polyatomic ion and tell me, so maybe type the name, not the formula. So tell me the name of this ion that has PO3. And the formula here doesn't tell you what is the charge on PO3. But you still can find it and tell me the name. Phosphate, yes. Phosphate. And the phosphate ion has for formula PO3 and 3 negative charges. So here, make sure you make the first 3 a subscript and the 3- a superscript, right? The 3- are the charges, and the 3 belongs to the oxygen, and it says you have 1 phosphate atom surrounded by 3 oxygens, and this ion carries 3 negative charges. So then next, the name. So looks like it will be phosphate in there, because for polyatomic ions, you just use their name as you find it in the list of polyatomic ions. That will be the second name. And what comes before that? Sodium, yes, of course. And sodium doesn't need a Roman numeral because it's a predictable ion, right? We know it's always Na+. Na plus phosphate. And so here the formula is confirmed. We understand now why we have 3 sodium for 1 phosphate. It's because 1 phosphate carries 3 negative charges, and so you need 3 positive charges from 3 Na plus to cancel that and make a neutral formula. So AlClO3 3 times. So tell me the cation. What is the symbol for the cation here? Okay, pay attention to the charge. Yes. So aluminum is in group 3A. It's another predictable ion. Group 1A, 2A, and 3A, those metals, I'm talking about the metals only, they are predictable. And the group number is equal to the charge. And because metals make positive ion, it's a 3 plus for aluminum because it's in group 3A. And now, okay, ClO3, again, that definitely looks like a polyatomic ion. The parentheses also hint at that. So tell me either the formula or the name. Writing the name is maybe easier. But it's something like ClO. Yes, ClO3. So we know from the formula of the compound that it's ClO3 because that's what is in the parentheses. And now we need to look at the list to find the charge. And yes, it's a chlorate, and chlorate has only one negative charge. And let me make it obvious by inserting this. And this should be a superscript. Charges are written in superscript, which means in the upper right corner. And so what's the name? So obviously we will have chlorate because we just use the names of the polyatomic ions as they are found. And that's aluminum. So do we need a Roman numeral here? Yeah, no. No, because it's a predictable ion again. Okay, so that's it for this one. SnO2. So what is the cation in there? So find Sn in your periodic table. Sn, yes. What is the charge on Sn? Ooh, yes, good. So before we do that, let's find the anion, because the reason is that Sn, you find that it's tin in group 4A, and tin in group 4A is not a predictable ion. So you don't know what is the charge from the position in the periodic table. However, you can retrieve it using the compound formula. And the reason is because oxygen is a predictable ion. So by finding how many negative charges we have from oxygen. So oxygen, what is the symbol for the oxygen ion? And it's called the oxide ion. So tell me, yeah. So let me change that. Oxygen is a predictable ion. It's a non-metal, so it's going to be a negative ion. And for non-metals, you do the group number -8. So 6 because oxygen is in group 6A. So 6 minus 8 is -2. Oxygen always makes the O-2 ion, and it's called the oxide ion. Okay, so, and we see here we have 2 oxygens per formula. So we have 2 times O-2, which means 4 negative charges in total. So, and then we have to cancel those 4 negative charges with 4 positive charges. And the 4 positive charges will be carried by the tin. And so tin, it's by itself, so it will have to carry all those 4 charges on that one tin. So that's how we find out the charge on tin. right? It's not from the position in the periodic table, because I see that it's in group 4A. You could think, oh, 4 plus, but hopefully you didn't think like that. And you need to retrieve the charge from the compound formula when you have a variable charge metal. Okay, so then the name. So tin. Let me give you some time. Yeah, so it's something like tin oxide. Is it really only that? So it's the metal's name, then the non-metal with the ending "ide", so that's all correct. But it's missing something. Yes. You need the Roman numeral here because, and so 4 is that. So you need the, yeah, be careful, it's 4. So I and capital V, because capital V is for 5. And when you place the 1 in front, it means you remove 1 from 5 and it's 4. So it's tin 4 oxide. Does it make sense? The Roman numeral stands for the charge on tin. It's not the subscript or something like that. It's the charge on tin. And here we found that it's 4 plus. So then it's tin 4. Okay, so let's do K2. Oh, yeah. Why would it have been obvious? So again, tin is in group 4A, but the group 4A, the metals from group 4A are not predictable ions. It's a variable charge metal. So hold on, I will look for the this shows the periodic table with the predictable ions, those that you can identify, or you know, you can find the symbol from the position in the periodic table. And for the metals, it's only group 1A, 2A, and 3A. And the group number is equal to the charge. And it's positive because these are metals. Notice how all the transition metals are not predictable. And also 4A and 5A and 6A are not predictable. And now if we move to the next slide, here, these are the metals with variable charge. With variable charge. So the transition metals, those metals in the B groups, are typically variable charge metals. And here it shows how, you know, chromium can be 2 plus or 3 plus, molybdenum, same, manganese, iron, cobalt, nickel, well, they all have 2 or 3 plus. I didn't notice that. So copper, cadmium, gold, and mercury are all, you know, making different kinds of ions. Among those transition metals, zinc and silver are exceptions. Silver is always +1, and zinc is always 2 plus. And notice how the group 4A is among those variable charge metals, because tin can be 2 plus or 4 plus, and lead can be 2 plus or 4 plus. So you need the formula of the compound to retrieve, you know, which one of these 2 ions it will be. So hold on. So hopefully we'll have another example. But let's continue with K2S. So what is the metal? I mean the cation there, and that's the metal. Cations are always the metals, unless it's ammonium. Okay, so what is the symbol for the cation in K2S? Yeah, what is the charge? K plus, right? K is the symbol for potassium, and potassium is in group 1A, atomic number 19. And because it's in group 1A, it's a predictable ion that makes a +1 charge, right? S, what is S? So find the anion symbol, please. Yeah. So S is coming from the sulfide. And that's also a superscript. Okay. That's sulfur. And sulfur is in group 6A. So you do 6 minus 8 and it's -2. So it's going to be a -2 ion. And we see that if you do the crisscross trick, the 2 from the charge on the sulfur becomes the subscript for potassium. So this makes sense. This formula makes sense. So now what is the name? So we said it's potassium. So tell me what is the name? Yeah. Oops. Potassium sulfide. Because you take the name of the metal and here it's potassium. Potassium is a predictable ion, so you do not add a Roman numeral. It's always K+. And then you take the non-metal and change its ending to "ide." So sulfur becomes sulfide. And that's it for this formula. Okay, let's do CrOH 2 times. So, okay, Cr, can you tell me what is Cr? So type the name. Chromium, yes. And chromium is in the B groups. It's in group 6B, atomic number 24, and it's a transition metal, right? If it is a transition metal, it's most likely a variable charge metal. So we don't know the charge on chromium. So we will have to find out from the formula that is given here, chromium OH 2 times. So then we need to go over the non-metal part and find out how many negative charges do we have in this formula. And this way we will find what is the charge on chromium. So here we have a polyatomic ion and it's OH, right? OH is a polyatomic ion and it carries 1 negative charge. Right? Okay, and we have 2, so hopefully you can now find out the charge on chromium. So I will let you try that. And tell me what is the charge on chromium now. So it's positive and it's so we have 2 hydroxide carrying a negative charge each. So that's 2 negative charges in total. And so they will have to be cancelled by the chromium, and there is only 1 chromium. So that chromium will carry those 2 positive charges to cancel the 2 negative charges from the 2 hydroxide. Right? Hopefully that makes sense. And so the name, it's chromium, chromium. Okay, so tell me the name. Yes, there is hydroxide. Hydroxide is the name for OH minus, and it's a polyatomic ion. So you keep it as it says in the table. And yes, we need a Roman numeral. And here it's for chromium 2 plus, so it's 2 chromium 2 hydroxide. That's the correct formula and name, sorry, for that formula.